Tonight, we're exploring ancient meteorites, mysterious stones older than Earth itself that may hold clues about the birth of planets, the dinosaurs' extinction, and even the origins of life. So get comfortable, relax, and journey into the deep history of the universe with Sleepy Origins. Before we begin, leave a comment telling me where you're watching from tonight. And if you enjoy videos like this, don't forget to like, subscribe, and thank you for being here. Long before there were oceans on Earth, before mountains, forests, clouds, or even the first breath of life, there were already stones drifting silently through the darkness of space. Not planets, not moons, just fragments. Cold pieces of rock and metal wandering through an unfinished solar system that did not yet resemble the calm arrangement of worlds we know today. In that distant age, the sun itself was still young, brighter, more violent, surrounded by a vast rotating cloud of dust, gas, ice, and debris stretching billions of miles into the blackness. If you could somehow stand inside that ancient era nearly 4.6 billion years ago, the solar system would not look peaceful. There would be no blue Earth hanging quietly beside the moon, no stable skies, no continents. The entire region around the newborn sun would resemble an enormous storm of glowing particles and colliding worlds. Everywhere, matter crashed into matter. Small rocks became larger rocks. Larger rocks became primitive worlds. And many of those worlds never survived. Some exploded apart. Some were swallowed by larger bodies. Some were thrown into deep space forever. And some of those ancient fragments are still here. Tonight, pieces of that forgotten beginning continue falling onto Earth as meteorites. That may be the strangest part of all. A black stone lying quietly in a desert today may actually be older than the planet beneath it. Older than every ocean. Older than every dinosaur, mountain range, and civilization ever imagined by humans. In some cases, scientists believe certain meteorites preserve material that has barely changed since the earliest formation of the solar system itself. They are not simply rocks from space. In a way, they are time capsules from before Earth existed. Most people imagine the solar system forming neatly, almost peacefully, with planets slowly appearing in empty space. But the reality was likely far more chaotic. The story probably began inside a massive molecular cloud, an enormous region of cold gas and dust drifting through the galaxy. Somewhere within that cloud, something disturbed the balance. Some researchers suspect a nearby supernova explosion may have triggered the collapse, though the exact cause remains uncertain. Whatever happened, gravity slowly pulled the cloud inward. As the cloud collapsed, it began spinning faster. At the center, pressure and temperature increased until the young sun ignited. Around it, the leftover material flattened into a rotating disk filled with microscopic dust grains. Those tiny grains began sticking together through static electricity, gentle collisions, and gravity. Over immense spans of time, particles became pebbles, pebbles became boulders, and boulders became objects dozens or hundreds of miles wide. These early objects are often called planetesimals, primitive building blocks of planets. But the process was violent from the beginning. Every orbit crossed another orbit. Every growing object competed for material. Some collisions created larger bodies. Others shattered entire worlds apart. Modern computer simulations suggest that during this era, impacts happened constantly. Entire regions of the early solar system may have looked like cosmic demolition zones glowing under the light of a young and unstable sun. And hidden within that destruction, meteorites were born. Many meteorites discovered on Earth today are believed to come from the asteroid belt between Mars and Jupiter. But even that statement hides a deeper mystery. Why is there an asteroid belt there at all? Why didn't those rocks simply merge into another planet? Part of the answer may lie with Jupiter. As Jupiter grew into the largest planet in the solar system, its gravity became overwhelmingly powerful. The giant planet disturbed nearby orbits so aggressively that many objects in that region could no longer combine peacefully. Instead of forming a stable planet, countless bodies remained fragmented. Some collided repeatedly. Some broke apart. Some were ejected entirely. In a strange way, Jupiter may have prevented another world from ever being born. And because of that, pieces of the solar system's earliest history remained trapped as scattered debris. Some meteorites are made mostly of stone. Others contain high amounts of iron and nickel. A few appear almost shockingly beautiful when cut open, revealing metallic crystal patterns that formed over millions of years as molten cores cooled extremely slowly inside ancient, shattered worlds. Those patterns, known as Wittmannsstatten structures, cannot naturally form under normal Earth conditions. They are evidence of cooling processes so slow and ancient that they almost feel disconnected from human time entirely. Certain meteorites may even be fragments of destroyed protoplanets, worlds that began forming but never fully survived. That idea changes the emotional weight of these objects. A meteorite is not always just debris. Sometimes it may be a surviving piece of a lost world that disappeared billions of years ago, before Earth even existed. And occasionally, scientists find something even stranger. Some meteorites contain tiny grains older than the solar system itself. Inside a few rare meteorites, researchers have discovered microscopic mineral particles believed to predate the Sun. These grains likely formed around dying stars long before our solar system was born. They survived interstellar space, became trapped inside the cloud that formed the Sun, and somehow remained preserved inside meteorites for billions of years, until finally landing on Earth. Which means a human being can now hold material older than the Sun in the palm of their hand. That realization is difficult to fully absorb. Most things humans touch belong to recent history. Wood, water, mountains, bones, all formed within Earth's long but limited timeline. Meteorites break that perspective completely. They connect Earth to something far older and far larger. They carry chemistry from an era before biology existed anywhere on this planet. and some scientists believe they may have done more than simply survive. There is a growing body of evidence suggesting meteorites helped shape Earth itself. Early Earth was repeatedly bombarded by enormous impacts during a period often called the Late Heavy Bombardment. Though details remain debated, many researchers believe countless asteroids and comets slammed into the young planet over hundreds of millions of years. Those impacts likely transformed Earth's surface again and again. Entire oceans may have boiled away before reforming later. The sky may have looked permanently filled with fire. Yet, hidden inside that destruction may have been ingredients necessary for life. Scientists have discovered amino acids, basic organic molecules connected to life, inside certain meteorites. Water-rich minerals have also been found in some samples. This has led to fascinating questions. Did meteorites help deliver part of Earth's water? Did they bring complex chemistry that later contributed to biology? Or were they simply carrying ingredients that naturally form throughout the universe? No one knows for certain, but the possibility changes the meaning of every falling stone. A meteorite may not just represent death from the sky, it may also represent creation. There is another unsettling detail about meteorites that people rarely think about. Most meteorites are not discovered immediately after they fall. Many sit unnoticed for centuries. Some land in oceans and vanish forever. Others bury themselves beneath ice, forests, or sand. Earth quietly hides them. Yet Antarctica has become one of the best places on Earth to find meteorites. Not because more meteorites fall there, but because the landscape preserves them. Dark stones stand out against white ice. Slow-moving glaciers also concentrate meteorites into certain regions over time, almost like nature gathering ancient artifacts into collections waiting to be discovered. Researchers working in Antarctica sometimes describe the experience as surreal. They walk across frozen silence, surrounded by some of the oldest ice on Earth, searching for rocks that may be even older than the planet itself. And every so often, they find one. A black fragment half buried in snow, a visitor from the beginning of the solar system. Perhaps the strangest part of this story is that meteorites are not rare in a cosmic sense. Earth is constantly collecting material from space. Tiny particles drift into the atmosphere every day. Larger objects occasionally streak across the sky as fireballs. Most burn apart before reaching the ground, but some survive. Right now, somewhere on Earth, an ancient fragment from deep space is probably lying unnoticed in a field, a desert, or at the bottom of the ocean. And inside that fragment may be chemistry untouched for billions of years. There is something deeply cinematic about that idea. Human civilization feels enormous from ground level. Cities glow across continents. Satellites orbit overhead. Digital networks connect billions of people instantly. Yet above all of it, ancient debris from the birth of the solar system still moves silently through darkness, exactly as it did before Earth existed. The universe has not stopped sending remnants of its past. And perhaps that is why meteorites continue to fascinate people across every generation. They do not simply tell us about space. They force humans to confront time itself. They remind us that Earth is not isolated. The atoms inside mountains, oceans, and human bodies were once part of much older cosmic processes stretching back before the sun ignited. In some sense, meteorites are not foreign objects invading Earth. They are surviving relatives from the same ancient origin. Fragments that never became planets. Fragments that witnessed the violent construction of the solar system. Fragments that traveled through endless darkness for billions of years before finally falling through Earth's atmosphere in a brief flash of light. And somewhere inside those silent stones may still be unanswered clues about how everything around us truly began. Out beyond the planets, far past the clouds of Earth and the warmth of sunlight reflecting off oceans, countless ancient objects are still moving through the dark exactly as they have for millions, sometimes billions of years. They do not have cities, atmospheres, or living creatures watching the stars from below. Most of them will never become worlds. They simply drift, silent, cold, almost invisible against the endless blackness of space. And yet, many of these wandering fragments have traveled farther and survived longer than anything humanity has ever built. Some began their journey before Earth even finished forming. Tonight, somewhere beyond Mars, a lonely piece of stone may still be floating through darkness. After surviving collisions, radiation, freezing temperatures, and gravitational chaos for nearly the entire history of the solar system. The strange part is that space sounds empty when humans describe it, but it is not truly empty at all. It is filled with movement. Every asteroid, every comet fragment, every grain of dust is locked inside a giant gravitational dance around the sun. Nothing stands still for long. Even the solar system itself is orbiting the center of the Milky Way galaxy at enormous speed, carrying all these drifting objects with it through interstellar space. Meteorites are not frozen relics sitting motionless in a museum of the cosmos. They are travelers. Some move slowly in predictable paths. Others are violently thrown into new trajectories after collisions that release more energy than entire nuclear arsenals on Earth. In the asteroid belt between Mars and Jupiter, impacts still happen regularly. Most are small. A few are catastrophic. When two rocky bodies collide at several miles per second, they can shatter each other apart instantly, sending fragments spinning outward into entirely new orbits. Some of those fragments eventually begin falling inward toward the sun, and occasionally, one of them crosses Earth's path. But before reaching Earth, many meteorites spend unimaginable lengths of time alone. Human beings struggle to fully understand deep time because our lives are short. A decade feels significant to us. A century feels ancient. But some meteorites wandered through darkness for hundreds of millions of years before arriving here. Entire species evolved and vanished on Earth, while these objects continued drifting silently through space, untouched. Dinosaurs ruled the planet and disappeared. Ice ages came and went. Human civilization rose from stone tools to satellites. Meanwhile, Somewhere in the blackness beyond Mars, a fragment of iron and rock continued orbiting the sun exactly as it always had. There is something unsettling about that kind of patience, especially because space itself is not gentle. Temperatures swing between extremes beyond anything naturally experienced on Earth. One side of a rotating object may face intense sunlight, while the other side remains near absolute zero. There is no atmosphere to soften radiation or shield against cosmic particles. Over time, high-energy radiation slowly alters the chemistry and structure of meteorites. Tiny atomic changes build up across millions of years. Scientists can sometimes estimate how long a meteorite traveled through space by studying those radiation effects, almost like reading invisible scars left by the universe itself. Some meteorites appear surprisingly dark and burned when found on Earth, but that black crust usually forms only during the final seconds of their journey while tearing through the atmosphere. Before that moment, many spent millions of years untouched in total silence. No wind, no rain, no sound at all. Just endless drifting beneath distant stars. It is possible that loneliness on Earth feels emotionally heavy because humans evolved on a crowded planet full of movement and noise. Space offers the opposite experience entirely: absolute isolation. Some asteroids tumble through darkness so far from major planets that nothing significantly changes around them for vast stretches of time. No sunrise in the way humans understand it. No seasons. No life. Just the slow turning of stone beneath cold sunlight. Yet, even in that silence, the solar system remains strangely unstable. Jupiter continues shaping the paths of countless objects with its enormous gravity. Some researchers describe Jupiter almost like a cosmic gatekeeper. The giant planet protects Earth from certain impacts by capturing or redirecting dangerous objects, but it may also send other bodies inward toward the inner solar system. Computer models suggest gravitational interactions can slowly nudge asteroids into unstable resonances where their orbits begin changing dramatically over time. A rock that remained safely in the asteroid belt for hundreds of millions of years may suddenly find itself pulled into a new path leading toward Earth. In that sense, some meteorites are not merely wandering randomly. They are gradually manipulated by invisible gravitational forces acting across enormous distances. And sometimes those journeys become even stranger. Scientists now believe a small number of meteorites discovered on Earth likely came from Mars. That idea once sounded impossible. But certain meteorites contain trapped gases matching the Martian atmosphere measured by spacecraft. The leading explanation is extraordinary. Massive impacts on Mars blasted fragments of the planet into space. Some escaped Martian gravity entirely and wandered through the solar system until eventually falling onto Earth. Which means pieces of another planet may already be sitting inside museums, laboratories, and private collections across our world. Imagine that for a moment. A stone resting quietly in someone's hand may have once been part of the surface of Mars beneath a salmon-colored sky billions of years ago. Some researchers have even explored whether microbial life could theoretically survive inside rocks traveling between planets, especially deep beneath the surface where radiation exposure is lower. The idea remains controversial and uncertain, but it raises fascinating possibilities. If primitive microbes ever existed on Mars long ago, could microscopic traces have survived inside ejected rocks? There is no scientific consensus that this happened, but the possibility alone changes how humans think about space. Planets may not be completely isolated worlds. Impacts might exchange material between them across cosmic time. And meteorites may quietly carry pieces of planetary history from one world to another. Even more mysterious are the rare objects now believed to come from beyond our solar system entirely. In recent years, astronomers identified unusual interstellar visitors passing through our cosmic neighborhood, including the elongated object known as Oumuamua. Its origin remains debated, and some of its behavior sparked intense speculation among scientists and the public alike. Most researchers believe natural explanations are more likely, but the discovery proved something important. Objects from other star systems can enter our own, which raises an unsettling question. Have fragments from distant stars already landed on Earth in the past without us realizing it? It is difficult to know. Most meteorites are incredibly ancient, and tracing their exact origins is often complicated. But the universe is old beyond comprehension. Stars formed and died long before the sun existed. Entire planetary systems may have been destroyed while Earth was still molten. Somewhere in that immense history, fragments from distant regions of the galaxy may have crossed paths with our solar system. The thought feels almost impossible to measure emotionally. A tiny rock sitting unnoticed in a desert might have traveled farther than any object humanity has ever launched. If you are still awake tonight, leave a comment telling me what time it is where you're listening from, and whether you think humans will someday travel as far as the meteorites already have. Because, in some ways, these silent stones are already the greatest travelers our species has ever encountered. Unlike spacecraft, they require no engines, no maps, no civilization. Gravity and time alone guide them through darkness. And despite all the violence of the universe, many survive. That survival may be the most fascinating part of all. Space appears chaotic, yet certain objects continue enduring through impossible spans of time. Some meteorites survived collisions that destroyed larger worlds. Others escaped gravitational traps that could have swallowed them forever. A few remained intact while drifting through radiation-filled emptiness for billions of years. By the time one finally falls onto Earth, its journey may already have lasted longer than the existence of complex life itself. And still, the story is not over once it arrives here. Humans cut meteorites open, searching for clues hidden deep inside their minerals and metals. Scientists study isotope ratios, crystal structures, and trapped gases, hoping to reconstruct forgotten chapters of solar system history. Every meteorite becomes a puzzle piece from a time before written records, before biology, before oceans or continents existed. Some researchers even believe certain meteorites preserve evidence of ancient magnetic fields from vanished worlds, allowing scientists to glimpse environments that disappeared billions of years ago. In that sense, meteorites are not only travelers through space, they are travelers through time. Messengers carrying memories from eras no human mind could ever witness directly. And somewhere tonight, far beyond the warmth of Earth, more of them are still drifting through the eternal dark, turning slowly beneath distant stars, waiting for gravity to eventually pull them toward another world. For most of human history, the night sky did not feel comforting. It felt alive. Ancient people looked upward and saw a world filled with signs, warnings, gods, and forces far beyond human control. The stars moved in patterns, the moon changed shape, eclipses darkened the sun without explanation, and sometimes, without warning, fire appeared in the sky. A glowing object would streak across the darkness, brighter than any star, burning for only a few terrifying seconds before vanishing beyond the horizon. To modern eyes, it is easy to call it a meteor, a natural event, a fragment of rock entering Earth's atmosphere. But thousands of years ago, nobody saw it that way. To ancient civilizations, the sky was not empty space. It was a realm connected directly to human fate. When something fell from above, people rarely assumed it was random. They believed something had spoken. In some cultures, a meteor crossing the heavens was interpreted as a divine warning before war, famine, or political collapse. In others, it represented angry gods, wandering spirits, or cosmic imbalance. And considering how dramatic some meteor events truly are, it becomes easier to understand why fear followed them for so long. Even today, a bright fireball exploding across the night sky can stop traffic and trigger panic calls to emergency services. Now imagine witnessing such an event in an ancient world with no astronomy, no satellites, no scientific explanation, and skies dark enough for every star to appear overwhelming. The experience would have felt supernatural almost immediately. Some of the oldest written records connected to meteors and strange celestial lights come from ancient China. Imperial astronomers carefully documented unusual objects in the sky because they believed heavenly events reflected the condition of the emperor and the state itself. Comets, eclipses, and meteors were all watched closely. In many dynasties, celestial phenomena were treated almost like messages from the universe, warning that political disorder or disaster was approaching. The logic may sound mystical now, but there was a deeper psychological pattern beneath it. Ancient rulers understood that when people become frightened by the sky itself, societies grow unstable. A blazing object crossing the heavens could spread fear faster than armies. Meanwhile, in ancient Greece and Rome, philosophers struggled to explain what falling stars actually were. Some thinkers proposed natural explanations involving atmospheric fire or celestial motion, but uncertainty remained for centuries. Aristotle himself believed meteors were atmospheric phenomena rather than objects from space. That view influenced scientific thinking for nearly 2,000 years. The strange irony is that even educated civilizations often underestimated the true scale of the universe. The idea that rocks could fall from outer space sounded irrational to many scholars for most of recorded history. In Europe, during the Middle Ages, reports of stones falling from the sky were often dismissed as superstition or folklore. Yet ordinary people kept witnessing them. Villagers described thunderous sounds, streaks of light, smoking craters, and black stones appearing where nothing existed before. Some communities treated these stones as sacred objects. Others feared touching them entirely. And perhaps the most fascinating detail is that certain ancient cultures unknowingly used meteorites long before humans understood where they came from. Thousands of years before the Iron Age fully developed, some societies were already working with iron taken directly from meteorites. Unlike most naturally occurring iron on Earth, meteoritic iron contains unusually high levels of nickel. Modern analysis of ancient artifacts has revealed that several early iron objects were likely forged from fallen meteorites rather than mined ore. One of the most famous examples may belong to ancient Egypt. The ceremonial dagger buried with Pharaoh Tutankhamun appears to contain meteoritic iron based on its composition. Imagine how mysterious such material would have seemed at the time. A metal harder and rarer than bronze, literally falling from the heavens. To ancient people, that was not just useful material, it felt divine. In fact, some ancient Egyptian texts referred to iron as metal from the sky. That phrase reveals something profound about human instinct. Long before modern science, people recognized that certain stones and metals did not belong to the ordinary earth around them. They sensed the difference, even if they could not explain it. Across other regions of the world, meteorites became part of spiritual traditions and mythology. Some Native American groups preserved oral histories describing fiery objects falling from the heavens. Certain sacred stones were believed to carry celestial power. In parts of the Middle East and Asia, black stones associated with heaven became objects of reverence and mystery. Historians remain cautious about connecting every sacred stone directly to meteorites because evidence varies widely from case to case. But the broader pattern appears repeatedly across civilizations. Humans consistently treated objects from the sky differently than ordinary earthly material. Part of that reaction may come from a deeper evolutionary instinct. For ancient humans, the sky represented both survival and danger. Rain came from above. Lightning came from above. The sun determined seasons, crops, migration, and life itself. When fire suddenly descended from the heavens, fear was almost unavoidable. And sometimes that fear was justified. Larger meteor events can be genuinely terrifying, even by modern standards. One of the most dramatic examples in recent history occurred in 2013 over Chelyabinsk, Russia, when a meteor exploded in the atmosphere with energy far greater than many expected from its size. Thousands of windows shattered, buildings were damaged. People who saw the flash moments before the shock wave often described confusion and panic. And that event happened in a world filled with science, communication networks, and immediate explanations. Ancient societies experiencing something similar would likely have interpreted it through religion, prophecy, or cosmic punishment almost instantly. Yet, meteorites did more than inspire fear. They also inspired imagination. Stories about stars falling to Earth appear across countless mythologies. In some traditions, meteors were souls crossing the sky. In others, they were celestial weapons or signs of battles between gods. The line between astronomy and storytelling remained blurred for much of human history because the sky itself felt deeply personal. Ancient people lived beneath true darkness. Without city lights, the night sky dominated human consciousness in ways difficult to experience today. The Milky Way stretched overhead with overwhelming clarity. Meteors appeared brighter. Constellations guided navigation, agriculture, religion, and timekeeping. The heavens were not background scenery. They were part of everyday survival and meaning. And occasionally, something would break that familiar order. A sudden fire streaking overhead disrupted the predictability of the stars. It reminded people that the sky was not fixed after all. Something unknown was moving above them. There is also an uncomfortable truth hidden inside many ancient reactions to meteorites. Humans are naturally frightened by randomness. A storm can be understood. A seasonal flood follows patterns. But a rock falling from the sky without warning feels deeply unnatural to the human brain. Even now, meteor impacts carry a strange emotional weight because they arrive from outside ordinary human control. A meteorite does not care about borders, empires, technology, or belief systems. It simply appears. That unpredictability helped shape countless superstitions. In medieval Europe, unusual celestial events were frequently linked to plague, war, or divine anger. Before major historical disasters, chroniclers often retroactively added descriptions of strange lights or fiery omens in the sky. Sometimes these reports may have been exaggerated after the fact. In other cases, genuine astronomical events probably occurred, but became woven into cultural fear and memory. Humans are storytellers by nature. When something frightening happens, people search for meaning. Meteorites became perfect symbols because they literally arrived from the unknown. And despite centuries of scientific progress, part of that emotional reaction still survives today. When people witness a bright meteor unexpectedly, the first response is rarely calm scientific analysis. It is usually awe or fear, or both at the same time. Perhaps that is because meteorites force humans to confront something ancient, buried deep in the mind. The realization that Earth is not sealed off from the universe. The sky is not merely decoration above civilization. It is active, dynamic, sometimes violent. Tiny fragments from deep space can still reach the ground beneath our feet at any moment. Ancient humans sensed that vulnerability long before they understood the mechanics behind it. In a strange way, their fear was not entirely irrational. They simply lacked the language of modern astronomy to describe what they were experiencing. And maybe that is why stories about falling stars continue to fascinate people even now. Somewhere deep inside human memory, the sky still feels mysterious. Even after telescopes, satellites, and space probes, there remains something unsettling about a bright object suddenly appearing overhead from the darkness beyond Earth. Because for a brief moment, it reminds us that the universe above our world is not distant at all. It is still reaching us. Most meteorites spend millions of years traveling silently through space, untouched by air, weather, oceans, or life. Then, suddenly, in the final moments of that journey, everything changes. A drifting fragment moving peacefully through the cold darkness of the solar system collides with Earth's atmosphere at speeds that can exceed 40,000 miles per hour. And in less than a minute, an object older than our planet may either vanish completely or strike the surface with enough force to reshape entire landscapes. The strange thing is that people often imagine meteorites falling gently from the sky like rocks dropping off a cliff. But that is not what really happens. By the time a meteoroid reaches Earth, it is already moving at extraordinary speed before gravity even begins pulling it downward. Earth is not simply waiting beneath it. The planet itself is moving through space around the Sun at nearly 67,000 miles per hour. Every meteor event is really the result of two objects meeting at incredible velocity inside a constantly moving solar system. And because of that speed, even a relatively small object can release shocking amounts of energy. Most meteoroids never survive the journey. The moment they hit the upper atmosphere, air resistance begins compressing violently in front of them. Temperatures rapidly climb to thousands of degrees. The glowing streak humans call a shooting star is not actually the rock burning like a piece of wood in a fire. Much of the light comes from superheated air and plasma forming around the object as it tears through the atmosphere faster than sound itself. For a few brief seconds, the sky becomes a tunnel of compressed heat and light. Some meteors glow white, others appear green, blue, yellow, or even deep orange, depending on their composition and speed. Iron-rich meteors often produce different colors than those containing magnesium or sodium. Ancient people saw these fiery streaks and imagined gods or omens because the events genuinely look unnatural. Even today, a large meteor crossing the sky feels strangely alive. There is something deeply primal about watching fire emerge from darkness overhead. Yet despite the violence of atmospheric entry, Earth's atmosphere is remarkably protective. Tiny particles strike the atmosphere constantly, every day. Most burn up completely, long before reaching the ground. In fact, Earth is continuously collecting cosmic dust without most people ever realizing it. Some scientists estimate that tons of microscopic extraterrestrial material settle onto Earth annually. Tiny fragments from space may already exist on rooftops, roads, oceans, and forests across the entire planet. But larger objects behave differently. As a meteoroid pushes deeper into the atmosphere, stress begins tearing it apart. Cracks spread through the rock. Outer layers melt and strip away in a process called ablation. Some objects explode violently before ever touching the ground. Others fragment into multiple pieces that continue falling separately. This is why meteorite hunters sometimes discover entire strewn fields where fragments are scattered across miles of terrain. And occasionally, the explosion itself becomes the most dangerous part. One of the most dramatic modern examples occurred above Chelyabinsk, Russia, in 2013. Early in the morning, a bright fireball suddenly crossed the sky with the intensity of a small sun. Dash cameras captured confused drivers staring upward as the object blazed overhead. Then, moments later, the shockwave arrived. Windows shattered across the city. Buildings were damaged. Thousands of people were injured, mostly by flying glass. What made the event especially unsettling was that the meteor itself never directly struck the city. The destruction came primarily from the airburst, an atmospheric explosion caused by the object breaking apart under enormous pressure. Scientists later estimated the energy release was equivalent to hundreds of thousands of tons of TNT. And yet, the original object was relatively modest compared to the truly massive asteroids known to exist elsewhere in the solar system. That realization unsettled many researchers because it demonstrated how vulnerable modern civilization still is to natural cosmic events. Humans tend to think of space as distant and disconnected from daily life. But meteor impacts are reminders that Earth remains physically exposed to the universe around it. Some impacts leave marks so large they permanently reshape the planet itself. In northern Arizona, the Barringer crater, often called Meteor Crater, stretches nearly a mile across the desert. For years, scientists debated whether it formed through volcanic activity or impact. Today, it stands as one of the clearest preserved meteor impact sites on Earth. Roughly 50,000 years ago, a large iron meteorite slammed into the region with enormous force, releasing energy beyond ancient humans could have imagined. The explosion excavated millions of tons of rock almost instantly. Standing at the edge of the crater today feels strangely surreal because the landscape itself appears wounded. It is evidence that even relatively small cosmic objects can violently alter Earth's surface in seconds. But not all impacts are obvious. Earth constantly erases its own scars. Wind, rain, oceans, tectonic activity, forests, and glaciers gradually hide ancient craters over millions of years. Some impact sites remain buried beneath sediment or hidden beneath water. Others may have disappeared entirely. Scientists suspect many large impacts occurred throughout Earth's history that humans may never fully identify. And occasionally, a meteorite lands quietly enough to create almost no drama at all. In 1954, a woman named Anne Hodges was resting inside her home in Alabama when a meteorite crashed through the roof, bounced off a radio, and struck her in the side. She survived with bruises, becoming the first known person directly hit by a meteorite. The story sounds almost absurd because the odds are so low. Yet, statistically, meteorites strike Earth every day, somewhere across the planet. Most simply land unnoticed in oceans, deserts, forests, or remote regions. The world is much larger than human attention. One of the strangest aspects of meteorites is how cold and ordinary they can appear after such violent journeys. People often expect freshly fallen meteorites to glow or remain extremely hot, but many cool rapidly during the final stage of descent. Once they slow significantly in the lower atmosphere, intense heating decreases dramatically. Some meteorites discovered shortly after landing were reportedly only warm to the touch. There is something eerie about that contrast. An object may arrive carrying the energy of a cosmic explosion, yet end its journey lying silently in dirt or snow like an ordinary stone. But sometimes the danger becomes global rather than local. Scientists now know Earth has experienced impacts powerful enough to transform the entire planet's climate. Massive collisions can throw dust, ash, and vaporized rock high into the atmosphere, blocking sunlight for extended periods. Wildfires, acid rain, earthquakes, and tsunamis may follow. Some researchers believe impacts have influenced the evolution of life itself multiple times across Earth's history. The most famous example remains the Chicxulub impact, connected to the extinction of the dinosaurs, though the full chain of environmental effects remains an active area of scientific study. What matters most is this: a sufficiently large asteroid does not simply create a crater. It changes ecosystems, oceans, weather patterns, and survival itself. That possibility still exists today. NASA and observatories around the world continuously track near-Earth objects, searching for potentially hazardous asteroids. Most known threats are not immediate dangers, but the effort itself reveals something important about humanity's relationship with space. For the first time in history, humans are attempting to monitor the sky not for spiritual omens, but for physical survival. Yet uncertainty remains. Smaller objects are harder to detect. Dark asteroids reflect little sunlight. Some may approach from angles difficult to observe near the sun's glare. The universe does not guarantee warning, and perhaps that uncertainty is why meteorites continue holding such psychological power over people. They arrive from beyond ordinary human control. A meteor can appear over a crowded city, a remote desert, or an empty ocean, without caring about civilization below. In a world increasingly dominated by technology and prediction, meteorites still remind humans that nature contains forces operating on scales far beyond politics, economics, or daily life. There is also something strangely beautiful about the final moments of a meteorite's journey. After drifting through darkness for millions or billions of years, its existence ends in light, a brief streak across Earth's sky, a glowing trail watched by strangers standing beneath the same night. Some people make wishes when they see meteors. Others feel fear. Others simply stare upward in silence. But almost everyone senses the same thing for a moment: that the universe is not far away at all. It is still touching Earth constantly. And somewhere tonight, another ancient fragment is already falling through the atmosphere, burning brighter and brighter as it races toward the ground, carrying with it a story that began long before human civilization ever looked up at the stars. Before Earth had oceans, before rivers carved continents or rain fell onto forests, this planet may have been a far more hostile place than most people imagine. Early Earth was hot, unstable, and repeatedly attacked by objects falling from space. Volcanoes covered huge regions of the surface. Lava moved across the landscape like glowing oceans. The atmosphere was toxic, thick with gases humans could never breathe. And yet somehow, against overwhelming odds, this violent world eventually became filled with water and life. The question that still fascinates scientists is whether Earth created everything necessary for life on its own, or whether part of the story arrived from somewhere else. Because hidden inside certain meteorites, researchers have discovered something unexpected: water-bearing minerals and organic molecules connected to the chemistry of life itself. That discovery changed the conversation completely. For centuries, meteorites were mostly seen as destructive objects, cosmic debris capable of creating craters and mass extinction. But modern science began revealing another possibility. Some meteorites may not only bring destruction, they may also carry ingredients for creation. And if that idea is true, then every ocean on Earth, every tree, every animal, every human being may owe part of its existence to ancient rocks that fell from the sky billions of years ago. One of the biggest mysteries surrounding Earth's origins involves water itself. At first glance, the answer seems obvious. Earth has enormous oceans. Water covers most of the surface. But when scientists began studying how planets form, a problem appeared. The inner solar system, where Earth formed, was likely too hot in its earliest stages for large amounts of water ice to survive easily. Young planets near the Sun experienced intense heat and violent impacts. So where did all Earth's water come from? Some researchers believe a significant portion may have arrived later through impacts from water-rich asteroids or comets. Certain meteorites, known as carbonaceous chondrites, contain hydrated minerals, materials chemically linked to water. These meteorites are ancient and relatively primitive, preserving chemistry from the early solar system. When scientists analyzed isotopes within some of these rocks, they noticed similarities between the hydrogen found in meteorites and the hydrogen present in Earth's oceans. The evidence is not perfectly conclusive, and debates continue regarding how much water came from meteorites versus Earth's interior. But the possibility remains powerful. It suggests that at least part of Earth's oceans may have cosmic origins. Imagine that for a moment. Every wave crossing the Atlantic, every drop of rain on a city street, every glass of water ever lifted by human hands may contain molecules delivered long ago by ancient objects falling through the darkness of space. And water is only part of the mystery. Scientists studying meteorites have also found amino acids, organic compounds connected to proteins and life. One famous example came from the Murchison meteorite, which fell in Australia in 1969. When researchers examined the fragments, they discovered dozens of amino acids, including some used by living organisms on Earth. The finding shocked many scientists because it suggested complex organic chemistry can form naturally in space without biology being present. In other words, the building blocks associated with life may not be rare accidents unique to Earth. They may emerge throughout the universe, wherever conditions allow certain chemistry to unfold. That idea quietly transformed modern astrobiology. Before discoveries like this, some people assumed life's chemistry might be extraordinarily isolated. But meteorites began hinting at a different possibility. Perhaps the universe naturally creates organic ingredients almost everywhere. If so, life itself may not begin with a miracle appearing suddenly from nothing. Instead, the cosmos may slowly assemble complexity, piece by piece, across millions of years, scattering ingredients between worlds through impacts and drifting debris. There is even a more controversial theory, known as panspermia. The basic concept is simple but unsettling. Life, or at least microbial precursors to life, might spread between planets carried inside rocks. Some versions of the idea suggest microbes could survive inside meteorites, protected from radiation deep within stone. Others propose that the chemistry necessary for life travels more easily than life itself. Most scientists remain cautious because no direct evidence proves living organisms successfully traveled between worlds and started life on Earth. But the theory continues attracting attention because it forces people to think differently about planets. Maybe worlds are not completely isolated systems. Maybe impacts connect them, and meteorites may act like cosmic carriers, moving chemistry from place to place over immense spans of time. Mars often enters these discussions because scientists believe early Mars once had liquid water, rivers, lakes, and possibly oceans. Some meteorites found on Earth are almost certainly Martian in origin, blasted into space by ancient impacts before eventually landing here. If primitive microbial life ever existed on Mars billions of years ago, could microscopic traces theoretically survive inside rocks ejected into space? No one knows. There is no accepted evidence proving Martian life reached Earth. But even asking the question changes how humanity views the universe. The line separating planets begins to feel thinner than it once did. Some researchers also suspect that the chemistry of life may begin surprisingly easily under the right conditions. Organic molecules have been detected not only in meteorites, but also inside interstellar clouds and distant regions of space. Complex carbon chemistry appears far more common than scientists once expected. This does not mean life exists everywhere. The jump from chemistry to living organisms remains one of the greatest unsolved mysteries in science. But meteorites reveal something important. The universe already knows how to build complicated molecules long before biology begins. In a strange way, space may be less dead than it first appears. Even so, uncertainty remains everywhere in this story. Some scientists argue Earth's water primarily came from internal geological processes rather than impacts. Others question how effectively fragile organic molecules could survive intense collisions with Earth's atmosphere and surface. There are debates over contamination in meteorite studies and disagreements about how representative certain samples truly are. That uncertainty matters because the origin of life is still one of the most difficult scientific questions humans have ever faced. No single meteorite has provided a final answer. Yet, piece by piece, they continue revealing clues. And perhaps the most fascinating part is that many of these clues arrive unexpectedly. Researchers cut open ancient rocks expecting geology, and instead discover chemistry connected to biology. Tiny minerals trapped inside meteorites become windows into conditions from before Earth's oceans even existed. It is almost as if the solar system preserved fragments of its own early experiments. If you're still listening tonight, I'd love to know what you think about this idea. Do you believe life on Earth began entirely here? Or do you think part of the story may have come from space? Leave a comment below with your theory. Because honestly, the deeper scientists look into meteorites, the stranger the boundary between Earth and the cosmos begins to feel. Humans often think of life as something fragile and isolated, protected only by the thin atmosphere surrounding this planet. But meteorites suggest that chemistry itself travels. Water travels. Carbon travels. The ingredients for biology move through the universe constantly, inside drifting rocks older than Earth itself. In some sense, the solar system may have been exchanging material long before humans existed to notice. There is also something emotionally unsettling about the realization that every atom in the human body once belonged to ancient cosmic processes. Carbon formed inside dying stars. Iron emerged from stellar explosions. Water may have traveled through space before reaching Earth. Meteorites compress all of those ideas into physical objects people can actually hold. A black stone lying in desert sand may contain chemistry older than mountains, older than oceans, possibly connected to the earliest pathways toward life itself. And perhaps that is why meteorites continue fascinating scientists so deeply. They are not simply rocks. They are fragments of unfinished stories. Some may preserve memories of ancient collisions. Others preserve chemistry from the birth of the solar system. And somewhere inside, certain meteorites may still be hidden clues about the moment when lifeless matter first began crossing the invisible boundary towards something alive. The universe has not fully explained that transition yet, but every time another meteorite falls onto Earth, it is possible that a new fragment of the answer arrives with it from the dark beyond our world. Not all meteorites are ordinary fragments of stone and metal. Some arrive carrying mysteries so strange that even after decades of study, scientists still debate what they truly mean. Certain meteorites contain impossible-looking structures, unusual chemistry, or stories so bizarre they almost sound fictional. Others appear connected to vanished worlds, ancient catastrophes, or unanswered questions about life beyond Earth. And perhaps the strangest part is that many of these objects spent billions of years drifting silently through space before suddenly landing in deserts, frozen plains, forests, or city streets where humans could finally examine them. In a way, the most mysterious meteorites feel less like rocks and more like messages from parts of the universe humans barely understand. One of the most famous examples began not in a laboratory, but in Antarctica. In 1984, researchers searching across the frozen Allen Hills region discovered a dark greenish rock partially buried in ancient ice. At first, it looked unremarkable compared to thousands of other meteorites collected there, but years later, scientists identified something astonishing. The rock, known as Allen Hills 84001, appeared to come from Mars. That alone was extraordinary. Yet the real controversy emerged after researchers studying the meteorite announced they may have discovered microscopic structures resembling fossilized bacteria trapped inside it. Suddenly, one ancient stone from Antarctica ignited a global scientific argument about extraterrestrial life. Some scientists believed the structures could potentially represent evidence of primitive Martian microbes that existed billions of years ago, when Mars was warmer and wetter. Others strongly disagreed, arguing the shapes were too small, too ambiguous, or explainable through non-biological chemistry. Decades later, the debate still has no universal conclusion. Most researchers remain cautious about claiming proof of alien life. But the meteorite permanently changed scientific thinking because it forced experts to seriously confront a question once considered almost impossible. If life ever existed on another planet, could meteorites carry traces of it across space? The unsettling truth is that Mars and Earth may have exchanged material for billions of years. Massive impacts on Mars can eject rocks into space, and some eventually reach Earth after wandering through the solar system. Right now, fragments of Mars are sitting inside museums and laboratories on Earth. Humans have touched pieces of another planet long before astronauts ever traveled there. And inside some of those fragments may still be hidden stories scientists have not fully decoded. Yet Mars is only part of the mystery. Some meteorites are strange because of what they contain rather than where they came from. In Namibia, one of the largest meteorites ever discovered still rests partly embedded in the ground where it landed thousands of years ago. Known as the Hoba meteorite, it weighs around 60 tons and consists mostly of iron and nickel. The object is enormous, yet no impact crater surrounds it. That detail puzzled scientists for years. Normally, something that massive striking Earth should leave dramatic damage behind. One explanation suggests the meteorite entered Earth's atmosphere at a relatively shallow angle and slowed significantly before impact, reducing the violence of the collision. But the event still feels strangely incomplete, almost as if an object of impossible size simply appeared on the surface without fully announcing its arrival. And then there are meteorites containing structures that seem almost too beautiful to be natural. When certain iron meteorites are sliced and polished, they reveal intricate geometric crystal patterns known as Wittmann-Statten structures. These metallic designs look almost engineered, like frozen circuitry or alien architecture hidden inside solid iron. Yet scientists believe they formed naturally over millions of years as molten metal cooled extremely slowly inside ancient planetary cores. The process requires cooling rates so gradual that similar patterns cannot easily form on Earth. Some of these meteorites may actually be fragments of shattered worlds, remnants of planetary bodies destroyed during the violent early history of the solar system. Holding one is like touching the exposed interior of a lost planet that no longer exists. But not every mystery involves chemistry or geology. Some involve sound. Throughout history, witnesses have occasionally reported hearing strange noises during major meteor events. Crackling, hissing, popping, or even whisper-like sounds occurring simultaneously with bright meteors crossing the sky. Under normal conditions, sound from distant meteors should arrive several seconds later because sound travels far slower than light. Yet some observers insist they heard noises instantly while watching fireballs overhead. For years, many scientists dismissed these accounts as imagination or psychological effects. But later research proposed a fascinating possibility. Certain meteors may generate very low-frequency radio waves that interact with objects near observers on the ground, causing materials like hair, eyeglasses, leaves, or dry grass to vibrate and create sound locally. The explanation remains debated in some cases, but it highlights something important about meteorites. Even now, humans do not fully understand every effect associated with these events. The universe still contains behaviors capable of surprising modern science. Another meteorite mystery unfolded over the skies of Siberia in 1908. Near the Tunguska River, something exploded above a remote forest with extraordinary force. Millions of trees flattened outward across hundreds of square miles. Witnesses described a blinding flash, shockwaves, and skies glowing strangely bright afterward. Yet, despite the massive destruction, no clear impact crater was ever found. Scientists generally believe the event resulted from an airburst, likely an asteroid or comet fragment exploding in the atmosphere before striking the ground. But because the region was remote and investigation occurred years later, many uncertainties remain. Over time, Tunguska became surrounded by speculation, conspiracy theories, and myths involving everything from antimatter to alien spacecraft. Most scientists support natural explanations, but the mystery still fascinates people because it demonstrates how destructive an object can become without ever reaching the surface. If Tunguska had occurred above a modern city, the consequences would likely have been catastrophic. Some meteorites are mysterious simply because they should not exist where they are found. In remote deserts, Antarctica, and isolated regions across Earth, researchers occasionally discover meteorites with compositions that appear extremely rare or difficult to explain. A few contain unusual isotopic signatures, suggesting origins from differentiated bodies, ancient objects large enough to partially melt and separate into crust, mantle, and core layers before later being destroyed. Others appear shockingly primitive, preserving chemistry almost untouched since the formation of the solar system. It is almost as if the universe scattered fragments from multiple eras of cosmic history across Earth's surface, like broken pages from different chapters of the same story. And then there is the possibility that some meteorites may not even belong entirely to our solar system. In recent years, The discovery of interstellar objects passing through our cosmic neighborhood forced scientists to rethink old assumptions. If large interstellar bodies can travel between star systems, smaller fragments likely can as well. A few researchers have explored whether unusual meteorites on Earth could theoretically contain material originating far beyond our own sun. Evidence remains uncertain, and extraordinary claims require extraordinary proof. But the idea itself feels profound. Somewhere on Earth, hidden inside a museum drawer, or frozen beneath Antarctic ice, there could potentially exist fragments older and stranger than anything humans currently recognize. What makes these mysteries especially powerful is that meteorites are physical objects. They are not distant galaxies viewed through telescopes. People can touch them, cut them open, hold them in their hands. A child standing in a museum can place their fingers on a fragment older than Earth itself. Few scientific subjects create that kind of emotional connection between humans and deep cosmic history. Meteorites collapse impossible distances into something tangible. They make the universe feel close. And maybe that closeness is why they continue unsettling people even now. Every mysterious meteorite reminds humanity that space is not empty silence beyond our atmosphere. It is active, violent, ancient, filled with processes and histories humans are still trying to understand. Somewhere tonight, countless unknown objects are still drifting through darkness beyond Earth. Some may carry chemistry unlike anything studied so far. Some may eventually burn across the sky, over oceans or deserts, centuries from now. And some may already contain answers to questions humanity has not even learned how to ask yet. For more than 160 million years, dinosaurs ruled Earth with almost unimaginable dominance. They crossed ancient deserts larger than modern nations, hunted through forests thick with giant ferns, and thundered across plains beneath skies no human eyes would ever see. Some grew longer than blue whales. Others hunted in packs with intelligence still debated by scientists today. Entire ecosystems revolved around them. If a human being could travel back into the late Cretaceous period, the planet would feel both familiar and deeply alien at the same time. Flowering plants existed, oceans teemed with life, insects buzzed through humid air, but enormous reptiles controlled nearly every environment. For millions of years, it may have seemed as though the age of dinosaurs would continue indefinitely. Then, in what was likely less than a single day, the future of life on Earth changed forever. Somewhere above the planet, an asteroid roughly 6 to 9 miles wide was falling toward Earth at extraordinary speed. It had probably traveled through space for millions of years before crossing paths with our world. No living creature on Earth understood what was coming. The object approached faster than a rifle bullet, carrying more energy than human civilization has ever produced combined. And when it struck near what is now the Yucatan Peninsula in Mexico, about 66 million years ago, the collision became one of the most catastrophic events in the history of life itself. The impact site is now known as Chicxulub. Today, much of the crater lies buried beneath layers of rock and sediment, partly hidden under the Gulf of Mexico. But the crater remains enormous, roughly 110 miles across. Its scale alone hints at the violence of the collision. In the first seconds after impact, temperatures near the blast zone may have become hotter than the surface of the sun. Rock vaporized instantly. Shock waves tore through Earth's crust with terrifying force. Forests near the region likely ignited almost immediately. Massive earthquakes spread outward across the planet. Tsunamis hundreds of feet high may have crossed ancient coastlines thousands of miles away. Yet the most devastating effects probably came after the initial explosion. The asteroid did not simply create a crater, it changed the atmosphere itself. Enormous amounts of dust, ash, sulfur compounds, and vaporized rock blasted high into the sky. Some scientists believe debris may have re-entered the atmosphere globally, heating the air and igniting fires across multiple continents. The exact scale of worldwide firestorms remains debated, but evidence suggests the aftermath was severe beyond normal human imagination. For a brief period, Earth may have resembled a planet on fire. Then came darkness. Dust and aerosols likely blocked significant amounts of sunlight from reaching the surface. Temperatures dropped. Photosynthesis collapsed in many regions. Plants began dying. Food chains unraveled. Oceans changed chemically. Entire ecosystems that had evolved over tens of millions of years suddenly faced environmental conditions they were never adapted to survive. The extinction was not completely instantaneous everywhere. Some species probably lingered for generations. Others disappeared rapidly. But eventually, around 75% of all species on Earth vanished. Most non-avian dinosaurs disappeared entirely. The planet entered a biological reset, unlike anything humans have ever witnessed. What makes this story especially haunting is how random it feels. Dinosaurs were not necessarily weak or poorly adapted. They had already survived volcanic eruptions, climate shifts, and environmental changes across immense stretches of time. Many species were highly successful. The asteroid simply introduced conditions too sudden and extreme for large ecosystems to absorb easily. In that sense, the extinction may have been less about failure and more about timing. If the asteroid had arrived slightly earlier or later, Earth's biological future could have unfolded very differently. Some scientists have even argued that mammals, including early ancestors of humans, survived partly because they were small, adaptable, and capable of living underground or consuming varied food sources. While giant animals struggled during environmental collapse, smaller creatures sometimes proved more resilient. That idea carries a strange emotional weight. Humanity may owe its existence not to dominance, but to survival during a planetary disaster caused by a random object from space. Without that asteroid, dinosaurs might still control much of Earth today. Mammals may never have risen to prominence. Primates might never have evolved intelligence comparable to humans. Cities, languages, technology music, history, all of it may depend on one impact lasting only moments. The deeper scientists study Chicxulub, the more unsettling the event becomes. Tiny traces of iridium found in rock layers around the world helped researchers connect the extinction to an extraterrestrial impact. Iridium is relatively rare in Earth's crust, but more common in asteroids. That thin global layer of unusual material became one of the strongest clues that something from space had changed life forever. It is astonishing to think that evidence of a single day still exists across Earth 66 million years later. A thin line in ancient rock quietly marks the boundary between two completely different worlds. Before the impact, dinosaurs ruled the planet. After the impact, they were largely gone. Yet even now, scientists continue debating important details. Some researchers believe massive volcanic eruptions occurring around the same period may also have contributed to environmental instability before or after the impact. Others argue the asteroid alone was catastrophic enough to explain most of the extinction. There are ongoing discussions about how long darkness lasted, how rapidly temperatures changed, and which ecosystems suffered first. Science rarely offers perfect simplicity, especially when reconstructing events this ancient. But few researchers doubt the central conclusion anymore. Something enormous struck Earth, and life changed permanently because of it. There is also something deeply cinematic about imagining the final hours before the impact. Somewhere on Earth, a dinosaur may have been walking through a forest, completely unaware that an object from deep space was already racing toward the planet. Oceans moved normally. Winds crossed ancient plains. Creatures hunted, slept, migrated, and nested beneath an ordinary sky. Then, suddenly, perhaps brighter than the sun itself, a new light appeared overhead, and within minutes, an age lasting over 160 million years began ending. Humans often think of history in terms of wars, empires, or civilizations. But the Chicxulub impact reminds us that Earth's deeper history operates on entirely different scales. Entire evolutionary eras can disappear because of cosmic accidents. Life on this planet is not isolated from the wider universe. Space reaches Earth physically, violently, sometimes permanently. And perhaps the strangest part is that similar asteroids still exist today. NASA and observatories worldwide actively track near-Earth objects, partly because scientists understand what large impacts can do. The probability of a civilization-ending asteroid striking Earth soon appears low based on current observations, but not zero. The solar system still contains wandering bodies capable of immense destruction. Humanity simply lives during a relatively quiet moment in Earth's history. That realization changes how people view the sky. Meteorites are no longer just beautiful streaks of light or ancient rocks sitting inside museums. They become reminders that Earth exists inside an active cosmic environment shaped by gravity, collisions, and chance. The extinction of the dinosaurs was not mythology. It was physics, a natural consequence of celestial objects crossing paths at enormous speed. Yet, from that catastrophe came opportunity. Forests regrew, mammals diversified, new ecosystems emerged. Birds, themselves descendants of dinosaurs, survived and spread across the planet. In a strange way, the asteroid both ended one world and opened another. Evolution continued writing new stories on the ruins of the old. And somewhere inside that long chain of survival, adaptation, and chance, humans eventually appeared beneath the same sky that once carried the object that ended the reign of the dinosaurs. Which means every person alive today exists partly because one ancient asteroid arrived at exactly the wrong place and exactly the right time. Somewhere tonight, buried beneath desert sand or frozen deep inside Antarctic ice, there may be a stone worth more than gold, diamonds, or almost any material humans have ever pulled from the earth. And most people walking past it would never notice. It would look ordinary at first glance, dark, burned, rough around the edges, but inside that object could be a fragment of Mars, a surviving piece of a destroyed ancient world, or chemistry older than Earth itself. Meteorites occupy a strange place in human civilization because their value has almost nothing to do with appearance. They are valuable because of where they came from, and because the universe creates them only rarely. In a world where humans can manufacture nearly anything, genuine meteorites remain beyond human production. No laboratory can truly recreate billions of years of cosmic history trapped inside one ancient stone. And because of that, some meteorites have become among the most sought-after objects on Earth. The modern meteorite trade feels almost surreal at times. Wealthy collectors spend enormous amounts of money to own pieces of the Moon, Mars, or primitive solar system material. Auction houses display meteorites beneath elegant lights like priceless works of art. Scientists compete to study rare specimens before private ownership removes them from public research. Hunters cross dangerous deserts searching for black stones hidden among endless rock fields. Entire economies now exist around fragments that spent millions of years drifting silently through space before falling onto Earth. Yet the real value of meteorites may not be financial at all. Some are considered priceless because they contain information humanity cannot obtain any other way. One meteorite can reveal chemistry from the earliest solar system, evidence of ancient impacts, or clues about planetary formation billions of years before humans existed. In some cases, a meteorite may preserve conditions from worlds no longer fully accessible to science. A rock from Mars found on Earth can sometimes be studied more closely than parts of Mars itself. That changes the meaning of value entirely. Humans are not simply buying stones. They are buying time, rarity, and access to cosmic history. Antarctica has become one of the most important places in this strange search. Not because meteorites fall there more often, but because the environment preserves them almost perfectly. Black meteorites stand out sharply against white ice. Glaciers slowly move and concentrate meteorites into certain regions over immense periods of time. creating natural collection zones where ancient objects accumulate. Scientists working in Antarctica often describe the landscape as otherworldly. Endless silence, frozen wind, temperatures capable of killing unprotected humans quickly. And, scattered across that icy emptiness, are rocks older than Earth, waiting to be discovered. Some meteorites found there have transformed planetary science completely. Others became intensely valuable to collectors because of their rarity and origin. But Antarctica is not the only hunting ground. Across North Africa, especially in regions of the Sahara Desert, meteorite hunters spend weeks searching barren landscapes where dark, fusion-crusted stones stand out against lighter sand. The work can feel almost obsessive. Most days reveal nothing. Then, suddenly, a hunter spots a blackened rock unlike the others nearby. And in that moment, everything changes. It could be an ordinary terrestrial stone, or it could be material that traveled across space for billions of years. In some desert communities, meteorites have become part of local economies. Hunters sell discoveries to dealers, scientists, or collectors overseas. Yet, this growing market has also created tension. Some researchers worry that scientifically important meteorites disappear into private collections before proper analysis occurs. Others argue that private collectors help preserve meteorites that might otherwise erode or remain undiscovered. The debate continues because meteorites exist at the intersection of science, commerce, and human fascination. They are both research objects and treasures. Some meteorites are valuable because they are incredibly rare. Lunar meteorites, for example, likely formed when ancient impacts blasted fragments of the moon into space. A tiny percentage eventually reached Earth. Before the Apollo missions returned lunar samples, humans had never directly handled confirmed material from another world. Today, moon rocks remain among the rarest natural substances available on Earth outside official government collections. Martian meteorites are even more emotionally powerful for many people. Holding a fragment from Mars creates a strange psychological effect, because Mars has occupied human imagination for centuries. Ancient civilizations associated it with war because of its red color. Modern science transformed it into a symbol of exploration, alien life, and future colonization. Then, suddenly, humanity realized pieces of Mars had already been arriving naturally on Earth for millions of years. Some Martian meteorites sell for astonishing prices because they combine scientific importance with emotional symbolism. They are pieces of another planet people can physically touch. Yet perhaps the strangest meteorite market involves objects known as pallasites. These meteorites are visually extraordinary when cut and polished. Transparent yellow-green crystals, called olivine, sit suspended inside metallic iron-nickel structures, creating an appearance almost too beautiful to seem natural. Some slices resemble stained glass windows built by the cosmos itself. Scientists believe pallasites may originate near the boundary between the metallic core and rocky mantle of ancient planetary bodies shattered long ago. If true, they are remnants from deep inside worlds that no longer exist. There is something haunting about that idea. A polished pallasite displayed inside a museum may once have formed beneath the surface of a planet destroyed billions of years before Earth developed life. And because these meteorites are both scientifically significant and visually stunning, they often command extremely high prices. But value can also emerge from stories. In 1992, a meteorite crashed into a parked car in Peekskill, New York. The fireball was captured on video by multiple witnesses across several states, making it one of the best documented meteorite falls in history. The damaged car itself became famous. The meteorite gained enormous attention not only because of its scientific interest, but because humans emotionally connect with stories involving randomness and survival. Meteorites feel personal when they intersect with ordinary life unexpectedly. A cosmic object older than Earth, smashing into a suburban vehicle, creates a collision between deep time and modern civilization that people never forget. Some collectors specifically seek meteorites connected to famous events because narrative increases value almost as much as rarity. Yet, hidden beneath all the auctions and collecting culture is a deeper truth. Meteorites remain valuable because they remind humans how small Earth really is. Every meteorite is physical proof that our planet exists inside a much larger environment filled with drifting debris, shattered worlds, and ancient material older than human imagination can comfortably process. A tiny stone sitting inside a glass case may contain atoms forged in exploding stars before the sun even existed. There is no ordinary price for something like that. And perhaps that explains why meteorites affect people differently than most rare objects. Gold is valuable because humans decided it should be. Diamonds are rare, but still formed on Earth. Meteorites feel different because they arrive from beyond the world humans evolved to understand. They carry emotional weight alongside scientific importance. They make space tangible. In recent years, researchers have also begun discussing asteroid mining, the idea that future technology could extract valuable metals from asteroids directly in space. Certain metallic asteroids may contain enormous amounts of platinum group metals worth unimaginable sums by current standards. On paper, some individual asteroids appear more resource-rich than entire regions of Earth. Yet this possibility creates strange philosophical questions. If humans someday gain access to limitless extraterrestrial resources, would meteorites lose their rarity? Or would naturally fallen meteorites become even more meaningful because they arrived on Earth long before humans reached outward themselves? No one knows, but the conversation itself reveals how humanity's relationship with meteorites continues evolving. Ancient people feared them. Modern science studies them. Collectors treasure them. Future civilizations may mine the worlds they came from. And somewhere tonight, another meteorite is likely falling unnoticed through Earth's atmosphere toward a desert, ocean, forest, or frozen plain. It may land silently. It may remain hidden for centuries. Or perhaps someday a human being will pick it up without realizing they are holding one of the oldest and most valuable objects they will ever touch. Not because of money, but because it survived the birth of worlds and carried that memory all the way to Earth. 66 million years ago, an asteroid changed the history of life on Earth forever. That much is now widely accepted by science. But once people truly understand that event, another question naturally follows behind it, like a shadow that never fully disappears. Could it happen again? The uncomfortable answer is yes. Not tomorrow, probably not anytime soon, according to current observations, but absolutely yes. The solar system that destroyed the dinosaurs still exists. The same gravitational forces still move asteroids through space. The same collisions still occur beyond Earth. And somewhere in the darkness right now, there are objects large enough to erase cities, devastate regions, or potentially alter civilization itself if their paths ever intersect with our planet. The difference is that modern humanity is the first species in Earth's history capable of looking upward and recognizing the danger before impact occurs. Yet even with telescopes, satellites, supercomputers, and global space agencies, the sky remains far larger than human awareness. Thousands of near-Earth objects have already been identified, but scientists know many smaller ones remain undetected. Space is simply too vast, too dark, and too dynamic for complete certainty. Some asteroids reflect very little sunlight, making them difficult to observe until relatively close. Others approach from angles near the sun's glare, where telescopes struggle to see them clearly. In a strange way, humanity is simultaneously more prepared than any civilization in history, and still deeply vulnerable. Most people imagine asteroid impacts as dramatic Hollywood events with years of warning and giant spaceships launching to save the world. Reality would likely feel far quieter at first. An astronomer notices unusual movement in telescope data. Orbital calculations begin. Scientists rerun simulations, repeatedly searching for errors. At first, probabilities remain uncertain, maybe one chance in 10,000. Then 1 in 1,000. Then perhaps higher. Long before panic reaches the public, there would probably be weeks or months of tense calculations happening inside observatories and research centers around the world. Because orbital prediction is difficult. Tiny gravitational influences accumulate over time. Close planetary passes alter trajectories. Even sunlight itself can slowly change asteroid paths through subtle heating effects known as the Yarkovsky effect. The universe does not move with perfect simplicity. Yet, despite those uncertainties, modern tracking systems have become remarkably advanced. NASA, ESA, and observatories worldwide continuously monitor potentially hazardous objects. Automated surveys scan the sky every night, searching for movement against the background stars. Some asteroids are discovered years or decades before close approaches. Others appear only shortly before passing Earth. Most turn out harmless. But every new detection reminds scientists of something important. Earth is not isolated from cosmic risk. One reason asteroid impacts feel psychologically different from most natural disasters is because they come from outside the planet entirely. Hurricanes form within Earth's atmosphere. Earthquakes emerge from tectonic movement, but asteroids arrive from the darkness beyond Earth. There is something deeply unsettling about that idea, because humans evolved believing the sky represented distance and safety. In reality, space remains physically connected to our world all the time. Tiny meteorites fall constantly. Larger impacts happen more rarely. Truly catastrophic collisions are extremely uncommon on human timescales, but Earth's geological history proves they do occur. The planet itself carries scars from ancient impacts across continents and oceans. Some craters remain visible. Others disappeared beneath erosion, forests, sediment, or water long ago. But the evidence remains written into the geology of Earth, whether humans notice it or not. One of the most sobering realizations in planetary science is that even relatively modest asteroids can create enormous destruction. A city-sized asteroid does not need to cause global extinction to become historically catastrophic. An object only a few hundred feet wide could devastate a metropolitan region depending on speed, composition, angle, and impact location. If it exploded in the atmosphere above a densely populated city, the consequences could be severe. The 2013 Chelyabinsk event in Russia offered a glimpse of this reality. The object was relatively small compared to extinction-level asteroids, yet its atmospheric explosion injured thousands of people, mainly through shattered glass and shock waves. And scientists had not detected it before arrival. That event became an important reminder that dangerous objects do not need to be enormous to matter. Yet, there is another side to this story that feels almost hopeful. Humanity has begun testing ways to defend the planet. In 2022, NASA's DART mission intentionally crashed a spacecraft into a small asteroid moonlet called Dimorphos. The goal was not destruction, but deflection, slightly altering the asteroid's orbit to test whether humans could eventually redirect dangerous objects away from Earth if enough warning existed. The mission succeeded beyond many expectations. For the first time in history, a species on Earth deliberately changed the motion of a celestial body. It was a small shift on a cosmic scale, but symbolically, it represented something extraordinary. The creatures, once helpless beneath falling fire from the sky, are beginning to learn how to push back. Still, many uncertainties remain. Deflecting a small asteroid with years of warning differs enormously from responding to a large object detected too late. Scientists continue debating the best long-term defense strategies. Kinetic impactors like DART may work for some threats. Other concepts involve gravity tractors, explosive devices, or even focused solar energy. Each approach carries technical challenges and risks. Fragmenting an asteroid incorrectly could potentially worsen the situation by creating multiple dangerous objects instead of one. Planetary defense is not science fiction anymore, but neither is it fully solved science. there is also a deeper philosophical layer hidden beneath these discussions. Humanity now lives in an era where one species is trying to protect an entire planet from cosmic events. No ancient civilization could even imagine such a responsibility. For most of history, humans simply endured nature. Now, for the first time, technology may allow civilization to influence outcomes that once seemed completely beyond control. Yet that power also creates anxiety. People begin wondering how many unknown objects remain out there. How much warning would we really have? Would governments cooperate globally during a genuine threat? Could civilization remain stable under the pressure of a predicted impact decades away? Science can calculate trajectories, but human psychology remains harder to predict. Interestingly, many astronomers who study asteroids regularly do not appear terrified by them. In fact, some describe asteroid detection as strangely beautiful work. Every newly tracked object represents deeper understanding of our cosmic environment. The same science that reveals danger also increases humanity's ability to survive it. Fear alone is not the dominant emotion in planetary defense. Curiosity plays a major role too. Scientists genuinely want to understand how the solar system works, because Earth itself exists inside that system, not outside it. And perhaps that is the most important shift in perspective meteorites and asteroids create. They force humans to stop thinking of Earth as a separate, protected world. Our planet is part of a larger celestial ecosystem shaped by gravity, impacts, orbital motion, and deep cosmic time. Life on Earth evolved under those conditions. Entire species disappeared because of them. Human civilization emerged during a relatively calm period between major catastrophes, but calm does not mean permanence. Somewhere beyond Mars tonight, asteroids continue colliding exactly as they did before humans existed. Fragments continue drifting into new orbits. Space remains active, ancient, and unpredictable. Yet, despite all of this, there is something strangely comforting about the fact that humans are finally paying attention. Ancient civilizations watched meteors with fear because they lacked understanding. Modern humanity watches with telescopes, mathematics, spacecraft, and global communication networks. The danger never disappeared, but awareness changed everything. For the first time in Earth's history, a species is actively searching the sky not only with wonder, but with responsibility. And perhaps that responsibility says something profound about human civilization itself. The same species, capable of war, pollution, and destruction, also built observatories to protect a planet spinning through darkness beneath an endless field of stars. Somewhere out there, another giant asteroid almost certainly exists. Maybe several. Some may never come near Earth. Others could pass safely millions of miles away. And one day, perhaps centuries or thousands of years from now, another truly dangerous object may appear in humanity's calculations. If that day comes, the future of life on Earth may depend not on luck alone, but on whether humans learned enough from the last great impact before the next one arrived. Long before Earth existed, before oceans formed, before mountains rose, before the first living cell drifted through ancient water, the universe was already creating the materials that would someday become everything familiar to us. The iron inside human blood, the calcium in bones, the oxygen in every breath, none of it began on Earth. These elements were forged in stars that lived and died billions of years ago. And somehow, fragments of that ancient history still survive today, inside meteorites scattered across our planet. That may be the deepest reason scientists continue studying them so intensely. Meteorites are not simply pieces of space. They are surviving records from eras no human civilization could ever directly witness. Tiny black stones found in deserts or frozen ice fields may preserve chemistry from before Earth even existed. Some contain minerals older than the sun itself. Others formed during the violent birth of planets. And together, they tell a story so vast that human history almost disappears beside it. One of the most astonishing discoveries in modern planetary science came when researchers realized certain microscopic grains trapped inside meteorites predate the solar system entirely. These tiny particles, known as pre-solar grains, formed around ancient stars long before our sun ignited. Some originated in red giant stars, slowly shedding material into space. Others likely emerged from supernova explosions, catastrophic stellar deaths, powerful enough to create heavy elements and scatter them across the galaxy. Those grains drifted through interstellar space for unimaginable spans of time, before eventually becoming trapped inside the cloud of gas and dust that formed the solar system. Then, somehow, they survived the formation of planets, asteroid collisions, and billions of years of cosmic chaos, until finally landing on Earth inside meteorites where humans could discover them. It is difficult to fully process what that means emotionally. A person standing in a laboratory today can hold material older than the sun. Few scientific facts feel more humbling than that. Human civilization measures time in centuries. Ancient empires lasted thousands of years. Meteorites casually extend that timeline into billions. They remind us that the universe was already ancient before Earth even formed. And yet, these objects also reveal something unexpectedly intimate. The solar system did not appear separately from the rest of the galaxy. It formed from recycled cosmic material left behind by earlier generations of stars. In a very real sense, meteorites preserve the memory of stellar deaths that happened before our world existed. Some scientists describe meteorites as fossils of the solar system, but the phrase almost feels too small. Fossils preserve biological history. Meteorites preserve cosmic history. They record conditions from a time when planets were still assembling through violent collisions and drifting debris. Certain meteorites contain tiny spherical inclusions called chondrules, which formed extremely early during the solar system's creation. Researchers still debate exactly how these structures formed. Some theories involve shock waves traveling through the protoplanetary disk surrounding the young sun. Others suggest rapid heating events caused by magnetic activity or collisions. No explanation fully resolves every detail yet. But what matters is this: meteorites preserve evidence from moments when the solar system itself was still unfinished. In some meteorites, scientists can literally observe the physical remnants of ancient processes that built planets. That makes these stones more than objects. They are archives. And perhaps the strangest thing they reveal is how chaotic the birth of worlds truly was. Human imagination often pictures planets forming peacefully, slowly condensing from dust into stable spheres, orbiting calmly around stars. The reality appears far more violent. Meteorites show evidence of repeated impacts, melting, fragmentation, and reassembly. Ancient planetary bodies collided constantly. Some partially formed worlds were shattered apart before completion. Others melted internally, separated into metallic cores and rocky mantles, then later broke into fragments after catastrophic collisions. A few meteorites may actually come from those destroyed worlds, which means some stones found on Earth are not random debris at all. They are surviving fragments of planets that no longer exist. There is something haunting about that idea. Entire worlds may have formed in the early solar system, only to disappear almost completely, leaving behind nothing but scattered meteorites drifting through space. Yet meteorites also reveal remarkable consistency across the universe. Many contain the same basic elements found throughout Earth and life itself: carbon, hydrogen, oxygen, nitrogen, iron, silicon. The ingredients of planets and biology are not unique to our world. The deeper scientists study meteorites, the more the universe appears chemically connected. The atoms inside human bodies are not separate from cosmic history. They are direct products of it. Carl Sagan once famously said, "Humans are made of star stuff," and meteorites provide physical proof that the phrase is more than poetic metaphor. Every heavy element essential to life was forged through ancient stellar processes long before Earth existed. Meteorites simply preserve part of that journey. There is also another mystery hidden inside the oldest meteorites. They may help scientists understand how common planetary systems truly are across the galaxy. If our solar system formed naturally through processes reflected in meteorite chemistry and structure, then similar processes may occur elsewhere around other stars. Modern telescopes have already confirmed thousands of exoplanets orbiting distant suns. Some systems look wildly different from our own. Others appear strangely familiar. Meteorites suggest planet formation itself may be a common outcome of star formation rather than a rare cosmic accident. And if planets are common, then the deeper question naturally follows: how common might life be? Meteorites cannot answer that directly, but they continue pushing humanity toward larger possibilities, especially because many meteorites contain organic compounds formed naturally in space. Carbon chemistry appears throughout the cosmos. Water-rich minerals exist on asteroids and distant moons. Interstellar clouds contain surprisingly complex molecules. The universe seems chemically active in ways scientists once underestimated. None of this proves life exists elsewhere, but it does weaken the old assumption that Earth's chemistry is uniquely isolated. In some ways, meteorites quietly changed humanity's relationship with the cosmos. Ancient civilizations feared stones falling from the sky because they seemed supernatural. Modern science revealed something arguably even stranger. Those stones connect Earth directly to processes occurring across billions of years and unimaginable distances. Meteorites collapse cosmic scale into something tangible humans can touch. A child standing in a museum looking at a meteorite is not simply looking at a rock. They are looking at material older than mountains, older than oceans, older than life itself. And somewhere inside that object is the memory of stars that died before the sun was born. Yet, despite all humanity has learned, enormous mysteries remain. Scientists still debate aspects of solar system formation, planetary migration, and the exact origins of Earth's water and life. New meteorites continue revealing surprises. Some contain isotopic signatures unlike expected models. Others preserve magnetic records from vanished worlds. A few seem to challenge assumptions scientists once considered stable. The universe continues, refusing to become completely simple. And perhaps that is part of what makes meteorites so emotionally powerful. They remind humans that existence itself is unfinished knowledge. No matter how advanced civilization becomes, there will likely always remain ancient objects carrying secrets beyond current understanding. Somewhere tonight, beyond the warmth of Earth, countless fragments still drift silently through space, exactly as they have for billions of years. Some may eventually fall onto distant planets orbiting other stars. Some may wander forever through interstellar darkness. And some may one day land quietly on Earth, carrying new clues about the origin of worlds, stars, or life itself. In the end, meteorites tell humanity something both unsettling and beautiful at the same time. Earth is not separate from the universe. We are part of an ongoing cosmic story that began long before humans existed and will continue long after us. The stones falling from the sky are reminders of that connection. Ancient messengers from a deeper past than human minds were ever designed to comprehend. And every time one lands on Earth, the universe leaves behind another fragment of its memory for us to discover. Thanks for spending this time exploring the ancient universe with me tonight. If you enjoyed this journey through meteorites and cosmic mysteries, don't forget to subscribe to Sleepy Origins for more relaxing space documentaries. Sleep well and keep looking up at the stars.